So in this video, we're going to learn about the different relationships between some angles. And that's really what we do in geometry, is we're always comparing and determining what relationships angles have in geometric figures. So this lesson is the start of all that. So let's get rocking and rolling. So first of all, we're going to take a look at this software that I have on my laptop called Geometer's Sketchpad. It's fantastic. It's what's called a dynamic geometry software program. Dynamic meaning that you can interact with it a little bit. It's not like when you say hello to it, it's going to say, hi, how are you? It's not that kind of interaction, but you'll see what I'm talking about. So whenever we see this icon, I'm going to click on it, and it's going to bring up a window. So what you see here, it's going to drag it over here a little bit. Notice I have two angles. I have angle ADC. Remember, when you name an angle, you name it by its vertices, with the vertex being in the middle. So angle D is the vertex of angle ADC. It's the green angle there. Its measure is 52 degrees. And likewise, angle BDC, in this case the red angle, has a measure of 128 degrees. And notice that they form what's called a linear pair. Remember, a linear pair are two angles that are adjacent to each other. They both share side DC, and they're formed from a line or a segment in this case. And what I'm going to do is I'm going to animate the point C. And that's going to move point C down to A, and then it's going to bounce back up. And notice that angle ADC is getting larger, and angle BDC is getting smaller. And then it kind of reverses itself. And the neat thing here is that while the angle is changing, the angle sum is not. So if we continually add together the angle measures, they sum to 180. So that's an important little relationship there about a linear pair. So I'm going to pause it there for a second, and let's come up with what we call a conjecture. And we're going to call this the linear pair conjecture. Conjectures are kind of like rules that we want to follow in geometry. So what is handy to do, as this eager student is doing in the picture on your screen, is they're starting a list of conjectures. So what we notice that if two angles form a linear pair, then they add it up to 180. So the geometry word for that is that they are supplementary. So a linear pair of angles are supplementary. And if you want to draw a little picture of it, you can. So maybe what we'll do is draw a segment there, and then from there we'll draw another segment that comes out to form our linear pair. And over here we'll put like angle 1, and over here we'll put like angle 2. And what we know about the angles is that the measure of angle 1 when added to the measure of angle 2 is equal to 180 degrees. We'll put that right underneath it maybe. So it's handy that when you have a conjecture that you kind of write it. Maybe I really suggest keeping either a separate notebook of conjectures or at least a separate section in your own notes. And it's the greatest way to study for a test, is just to take a look at your conjecture list. And if you understand what those conjectures mean and can apply them, you're going to find geometry to be pretty easy. So let's keep going. The next conjecture we're going to talk about is about the vertical angles. So what I'm going to do is I'm going to go back to my Sketchpad diagram for me. I'm going to click on the vertical angles tab. So this time, what you'll notice is that you have two lines, or in this case, two segments that intersect. Their intersection point is right here at the middle. And I'd like you to watch what happens and try to think about what it's showing you. Here we go. Let me click the button. So tell me, what did you notice? So I'll run it one more time for you. The red angle rotates around to the other vertical angle. So what's true about the measures of the vertical angles? So if you're telling me that the vertical angles are congruent, you are correct. Vertical angles are congruent. So let's draw a picture of that for our notes as well. We'll draw two intersecting segments or intersecting lines. Let's call that angle 1. Let's call that angle 2. We'll put that one up a little bit more. And what we know is that the measure of angle 1 is equal to the measure of angle 2. Or if we want to write it using our congruency, which I think is a little bit better to do, we'll say that angle 1, and I'm going to make a congruent symbol in a minute. Angle 1 is congruent to angle 2. There's my little squiggle. Remember, that little squiggle above the equal sign implies that they're congruent, and congruency means they have the same measure. So two big conjectures for today. The linear pair conjecture that says a linear pair of angles are supplementary, and the vertical angle conjecture saying that vertical angles are congruent. Cool. So what I'd like you to do is to determine the measure of angles 2, 3, and 4. The measure of angle 1 is 43 degrees. All right, so what you probably noticed was that angle 1 being 43 degrees is a linear pair to angle number 2. So, knowing that the linear pair of angles are supplementary, if you do 180 and subtract 43 from that, let's space it out a little bit more, we get 137. So the measure of angle 2, and I'll kind of write it up here, is 137 degrees. Now, you know that angle 2 and 3 form a linear pair of angles. They're supplementary, so 180 minus 137 is 43 also. Or maybe did you notice that angles 1 and 3 are vertical angles, and vertical angles are congruent? Either way, you should get that angle 3 is 43 degrees. And then either using the linear pair conjecture or the vertical angle conjecture, you can get that angle 4 is 137 degrees. And one last thing we want to tackle for today is using the linear pair conjecture. Let's explain why the vertical angle conjecture can be considered to be true. What you might notice about, say, angles 1 and 2 is that the measure of angle 1 plus the measure of angle 2 is equal to 180. Now, if we also take a look at angles 2 and 3, for example, they form a linear pair. So the measure of angle 2 plus the measure of angle 3 is equal to 180 as well. Now, let's use a little bit of algebra. Oh, no, not algebra. Yes, some algebra. Algebra is helpful in this case because I have two angle sums of 180. What that's going to mean is that the measure of angle 1 plus the measure of angle 2 is actually equal to the other angle sum. The measure of angle 2 plus the measure of angle 3. Now, do you notice that the measure of angle 2 is on both sides? So that kind of means that they cancel each other out. So that leaves us with the measure of angle 1 is equal to the measure of angle 3, which is kind of what our vertical angle conjecture says. So hopefully this lesson on angle relationships helped you determine some pretty neat conjectures about the linear pair of angles and also vertical angles.